Okay, so we're just going to try to tackle this problem here, of which is rate as your vessel departures at Sodwana Bay and from a pilot's boarding point at 0942. Your set ground track of 237 true. You are aware of the current which set at 341 true and at 2.5 knots. Your log speed is 17. So first, what you need to know what is a pilot boarding point. So where a pilot comes in on board, or where the pilot can come in and go out on your ship on this point. This point is normally denoted by a sign, but it's just a circle and a diamond inside. If I did call it diamond sign, normally shaded. So this is a pilot boarding point. So they're saying that your vessel departed Sodwana Bay from pilot's boarding point, and this is our Sodwana Bay here. Now we're talking about boarding point, of which is this one. Obviously this one, because this is our harbor. So we're leaving from this harbor. This is where a pilot should come in or go out. So at what time? At 0942. So we can just write our time there, 0942, next to our boarding point of it. This is where we go. This is the time at which we departure on a pilot's boarding point, of which is 0942. Then from then we set a track of 237 true. From this point we set a ground track. So then if you're setting a track, you know what you need to use. You're going to use your parallel ruler and go to your rows, your compass rows, and take that track straight to your point of which you departure from. So we said we're departing from a point, or with the with a ground track of 237. We're going to find our 237. 237, where are you? 237, something about here. 23, and then I put it here. This is 29, 28, 27 is here. So I'm leaving from a departure point, of which is just here. From its center here, you can start growing your line, of which is what? It's your ground track. So your ground track is 237, of which you just write here, and then you just move the parallel ruler, and from a pilot's boarding point we do our track. We do our track from our pilot's boarding point, of which is this one. And what else? Then we set that ground track, and we are aware of the current. So from here it's 942. You know that there is a set. There is a set, or should I say there's current setting at 341. So from here the current is pushing you at 341. So you're just going to go back to your compass rows and take that 341 and put it back to the point where you started. So it's 341 true. So you're just going to find our 341. This is our 341 is something about here. So I put it here, 341, it's something there. Then I'm going to move back to my pilot boarding point, of which this is where we start. And then then the current is pushing us this way. Or should I say the current set at 341. After we know that this current set on 341 and it's recorded, we now know the speed, or should I say the rate of the current. That's how it is called. The speed of current is called rate, and its descent is called drift. Okay, now we know that it had a speed of 2.5. Since we given a set and the speed, we're going to use a 1 hour rule. In a 1 hour rule, what we do, we just assume that the whole thing took about 1 hour to happen. So we're just going to use our distant triangle, of which is DST. So speed is going to, so let me talk about distance. Distance is going to equal to speed times time. where your time will be what? Will be, your time is 1. So distance is going to equals to speed. So when you have the calculation that you're doing, in this case, your speed and distance will be the very same thing, because you're using what? A 1 hour rule. So it's just effect of 1, doesn't change anything. So what else do we do? We're looking for what? 3. Let me use my tool here. You're looking for a distance of 3. Where is it? 2, 5. We're just going to measure here. Remember, you only measure here, you don't measure here, okay? So your distance. So if my distance was 2, 5. So I just start from any point, then 2, then 5 is about the half of it, of which is about there. Now I have it, right? We're good. So then we can come back on in our pilot's boarding point or initial point and mark that 25 knots, 25 knots, of which for 1 hour rule is equal to 1 nautical miles. So we now know that it will take us still here. The curve is going to take us to this position. So what else can we do after that? We do know our log speed. Remember, this is our log speed. Just because with 1 hour rule, your speed becomes distance. Remember, so we're just going to take that 17,5 and measure it there as distance. This is a 1 hour rule, so we're just going to measure 175, 5, 10, 15, 7, 2 and half of it. So I just measure it, just a meagle, yes, almost something like this. Check 5, 10, 15, 2 and half, 17.5. Then we measure that from where the set put us. So we just oh, I need to extend my line. So then I extend my line because I was supposed to mark over there, but my line can't go that far. So we're just going to extend our line, make sure it's still parallel to the previous one. With it, my HB pencil, extend my line. Okay, then I still have this one, 17.5. We put it here, we mark 17.5. My 17.5 is marked in there, I mark it here. 17.5 is something here. So now we're just going to join this line, and these lines are going to be our course to steer to counteract the current. So we join these lines, join these points, should I say. We join these points, and this is going to be our course to steer. Then we go back to our compass rose, using our parallel ruler. Remember, we read this side of the compass rose because we're moving this way. This is our from initial point, pilot boarding point, moving away from it. So this is it, we move there. And we read something like 229. You can 229. We just read 229. Then we go back to our answers. Checkmate. Yes. 229 degrees true is our course to steer.